In this example, we're asked to determine the slope and vertical intercept of the linear function that generates the following tables of values. So here's a spot for the slope, and here's the spot for a vertical intercept, which we should list as an ordered pair. So first, let's just take a look at the table and try to look for some patterns so we can get a feel of things. So looking at the x values as we go down the list, it looks like it's -2, 0, 2, 4, 6. So notice these are all going up by 2. And now looking at the y values, we start with 8, then we have 6, then 4, then 2, then 0. So these are each going down by 2 from one value to the next. Okay. And this tells us, since these numbers match up, any ratio will match up, and this tells us that it is in fact a linear function, which we were given, but it's nice to see that. So for every change of x of +2, the y changes by -2. So slope, which we sometimes call m, is the ratio of the change in y over the change in x. And another way we can compute this is you can take any 2 points where x1, y1 is corresponding values of one point and x2, y2 is corresponding values of another point. So I'm just going to pick 2 points, and we can actually, you'll see from this pattern, we could have figured it out without using this whole formula too. So I'm going to pick -2, 8, and how about 4, 2? So let's use a pen. We'll say this is my x1, y1, and this is my x2, y2. And it doesn't matter which one you call 1 or which one you call 2, as long as you're consistent in the formula. So y2 is 2 minus y1, which is 8. x2 is 4 minus x1, which is -2. Notice that I subtracted a negative. Sometimes students forget the subtraction sign when the second number is negative, but it's very important that you keep it. And if we compute this, we'll get -6 over 4 minus -2 is 4 plus 2, which is 6, which is -1. So our slope is -1. And notice we could have seen this directly from the table by just realizing for every -2 change in y, there's a +2 change in x, which is equivalent to -1. So that's how you can use the table. You can use consecutive values, and if you take the difference, notice you're just subtracting the y values. Take the difference in the x, you're just subtracting the x values. Okay, now we want to find the vertical intercept as an ordered pair. And this is actually given in the table, but let's think about what it means to be a vertical intercept. Well, you have some line, and this is the point that we call the vertical intercept. And since this is x and y, we'll use x and y here. So the vertical intercept, it's called that because it crosses the vertical axis, which in this case we're calling the y-axis. So notice if you're at the vertical intercept, your x value must be 0. X is 0 at the vertical intercept. And this is because anywhere on this line, you're not moving. This is the origin 0, 0. This would be x is 1, x is 2. Here x is -1, x is -2. If you're on the vertical intercept, your x isn't going right or left. You're only going up or down, which means the y value is different. So looking at the table, well, here's where x equals 0. So the y value that corresponds is 6. So we can read that directly from the table. Let's write this as an ordered pair. So 0 isn't nothing. You have to include it because it tells us the location that it's on the y-axis. 0, 6 is our vertical intercept.